Here I have a bunch of parts put together to make an assembly. As you can tell, as I move things, the other parts are able to react. So let's go through in this video today what assemblies are and how to make them in ways that show parts moving realistically together. Let's start off in the part modeling environment and show two ways of making the same part. In the XY plane, I'll create a rectangle whose corner is on one part of the origin. We'll make it a 6 by 6 rectangle, and I'll extrude that another 6 to make a 6 by 6 by 6 cube. And you'll notice the origin is on one corner of the cube. Let's save that. Let's make a new part now, sketching on the same plane. And I'll use a rectangle by center, and we'll again assign that to be a 6 by 6 rectangle, but with the origin in the center this time instead of on a corner. We'll deactivate and extrude that, but this time we'll go mid-plane and make a 6 by 6 by 6 cube, except the origin now is in the direct center of the cube. Everything else about the parts is the same. We'll save that. These two cubes, with one with the origin in the middle and one with the origin on the corner, make for an excellent conversation on one of the most important parts of an assembly, the first part we put in. I'll click here to go into the assembly environment, and I'll insert the cube that has the origin on the corner. You'll notice I can click anywhere, and every time I click, I can insert a new cube. And I have a disaster. So let me hit Control Z a few times, and let me reinsert our corner cube, but this time we should do it with intent. So when I put this on the origin, you'll see as I hover my mouse over the origin, this little origin symbol that shows up. Let's look at it from the front. And that tells me that if I click, the origin of my part will be aligned with the origin in the assembly. So if I click, you can tell that we are now aligned. The origin lines right up on that corner, and I can finish. That's very useful. Now, of course, I can freely click and drag this to any position that I wish, but if we've just aligned it to our origin and we want it there, I'll hit Control Z to make sure that we're still aligned on our origin. I'll right click and say Anchor Part. And this is the best practice. Let me show you why. If I go to insert my other cube with the origin at the center, and then I hover over that origin and I anchor the part, then all the other parts that I insert can be mirrored across my assembly planes. So I highly recommend making your first part the foundational part that all the other parts link to that doesn't move, and anchoring it on the origin as I have here, and then all of the opportunities for parts and mirroring and everything are properly done with my XY and YZ and XZ and ZX planes placed in meaningful ways, since I've aligned the origin with my part to the origin of the assembly. So let's make that the first foundational thing that we do when we make an assembly, and let's go ahead and start with an example assembly now. So now that we're in the assembly environment, we're immediately prompted to start inserting parts. I'd like to build the jaw assembly of the vise first. And so I'm going to insert my jaw and open. Now, as before, I'll stand on the origin where I can see the origin symbol and make a click. And then I'll click Finish, and I'll be sure to anchor my part immediately. And now, if I so wish, I have certain planes that I can mirror things across. And I am just well set in my assembly relative to the alignment geometry, relative to the assembly geometry. I want to insert another part now, and so we'll go to Insert Design. And I'll go to my main jaw, and I'll insert that next, and finish. Next, I want to make a relationship between these two parts. It can be important to mention that there are 6 degrees of freedom that every part has in an assembly. I can move up and down, I can move side to side, and I can move front to back. I also can rotate around the Y, X, and Z axes. These linear movements and the ability to revolve around the axes add up to 6 different degrees of freedom or ways that the part can move. And we wish to reduce the degrees of freedom into what would be realistic movement for the part. For instance, I know that I want this face and this face to be on the same plane, to be coplanar, or also known as coincident. And so I'll go with constraint right here, and I have my face selected. I'll select this face, and Alibre automatically applies the coincident command. And this makes the faces, say, share the same plane. So if I apply this command, then no matter how I move this part, these faces will always now share the same plane. I have this circular face and this circular face, and I know that I want them to share the same axis, the central axis that would run through the center of a circular face. So I can choose the 2 circular faces, and Alibre automatically chooses the coaxial command. And if I apply that, then now the only degree of freedom that this part has is to revolve around the one axis, in this case the Y axis. And that's exactly what we want. We simply want to reduce our degrees of freedom. So let's insert the jaws that go into here. I call them the subjaw, and I can insert 2 subjaws. Now I can do the same constraint where I click on constraint, and I want to make these share the same plane. I also have an option to choose an offset. And with my offset, I can choose a specified distance that I want them to be apart. I can say I want them to be 1 inch apart, and now however I move them, it's stuck being 1 inch apart. I also can choose an angle, and I can say I want this to be 15 degrees off of the other face, and we can give it an angle in that manner. But of course, I want plain coincident and nothing else. So I'll apply that, and again, I'll apply being coaxial. This has me, this is asking if I want my axes to be 1 inch apart, or I can say 0.5 inches apart, or so on, but of course I simply want a 0 offset. And we'll apply that. So as you can tell, now our parts are interacting in a more realistic way, but it's kind of jumping around because they have so much freedom in what they do. Well, how might we address that? Well, I can select this face, and I can hold Shift and select this face. And it tells me that it's overdefined because if I were to make this face coincident with this face, then it would break other alignments that I have. It's impossible. But I can always specify an angle. And I can say I want these to be 90 degrees apart. And if I apply that and close, why now this face and this face are always going to be 90 degrees apart, but it's a little bit inherent in the design that I need this green part to still twist around a little bit. And so this mate does not satisfy my needs. I need to have some free play in there. So what I can do is edit my angle constraint, and I can establish limits, and I can say, okay, I want this to go from 75 degrees and 105 degrees, but have no more play than that. And now I can twist this from 75 to 100 degrees, and it won't pivot any more than that. So we can establish limits on our mates as well. Let me demonstrate that here as well. Perhaps I can select this face and choose constraint, and then I can choose another face, and 75, we'll go to limits here, we'll say 75 to 105, and apply that. And now this face is also limited. So let's go to constraint, and we'll make sure that we are coincident there. We'll make sure that we are coaxial here. And then I can select this face and say this face. And of course we're overdefined if we try to make it coincident, so instead we'll select angle, we'll select limits, and we'll make 75 to 105 and apply that. And there we are. So I'm going to insert a design, and we're going to go with our two sub jaws, if you like that naming convention, and I'll do the same thing as before. So you just saw me in fast motion apply each of these sub jaws that will have our teeth in there. But is there an easier way to do this? For that, let me delete one of these, and let's investigate patterning some of our parts. So I can go to linear pattern, and I can choose this part to pattern. I can choose a path, which would be down this line. And for rows, I can add another one. And for spacing, I'll say 1.884, which is the distance from this arc center to this arc center. And then we'll say OK. And I've been able to create a new pattern of this finger. Now you'll notice I have to wait until I've moved my part, and I might have to regenerate, but this is a way that we can save a lot of time, and it just regenerates instead of moving live. But we can pattern our parts quite easily doing that, and especially if you have parts that don't move too often, there's pretty much going to be no downsides at all. So we've been able to pattern parts, and we can also use circular patterns in the same way that we use circular sketch patterns, by the way. You just choose an axis, you choose your angles, the number of things that you want, and you're good to go. So we can both do linear and circular patterns. Mirror is a little bit different than we have in the part environment. It's a lot more advanced. We'll cover that probably in a different video. But we've been able to create a jaw assembly, if you will. And lastly, I'll just add teeth. So insert design, and teeth or fingers, whatever you wish to call them. So I've gone ahead and applied mates to my teeth here, or you can call them fingers, whatever you'd like. And they're moving in somewhat realistic ways. Again, noting our one pattern piece just takes a second to update when the parts are done moving. So now that we have our jaw, let's save this as an assembly. I'll close, and from here, start a new assembly. I like to insert the base of the vise into this new assembly. And again, I align on the origin. I finish and anchor the part. From here, I have a guide that is meant to go into this channel. So we're going to say Insert Design, Moving Block, and I'll insert my guide. Again, I have this lip right here, and I want to make sure that it's concentric with this, or we can also say coaxial. So we'll add a constraint, select my face, and now these will always move in a coaxial fashion. I want this face to also be aligned with this face, and so we can choose coincident because they are on the same plane when these circles are coaxial. If they're not, but we want them to be parallel, I can always choose my angle mate and say enter a degree of 0 degrees in there and achieve the same result. So that would work as a parallel mate. Now, I can insert all of my jaw components and build the vise from scratch, but since I have two jaws, I'd find it much easier to insert them as the assembly that we've made. I'll choose Insert Design and insert the jaw assembly that we've made as a video. And from here, I'd have to line up my bolt holes correctly. And so I'll choose Constraint, and I can choose one bolt hole to be coaxial with another bolt hole, and make sure I choose the coaxial constraint and apply that. And then I can do the same thing for the other bolt hole. Apply. So with that being done, these are my degrees of freedom so far, right? It's very convenient to be able to click and drag to find your degrees of freedom. But I would now like to insert a constraint and have this face rest upon this one. I'll give that a distance of 0. Now notice I inserted a part that is incorrect, right? It's facing the wrong way. And I did that on purpose to demonstrate how we can edit some of these constraints. So right now I have this coaxial, and you'll notice when I hover in my tree over the coaxial constraint, it highlights the faces that are constrained. So I can edit this, and I can simply choose reverse or flip. And of course it flips my jaw, but now this is in the correct orientation. That's a huge advantage. So I can go find the coaxial constraints of my jaw, and as you can tell, I've constrained it in this manner. So I'll have to delete my coaxial constraints in order to update this. And it's as simple as right-clicking and saying delete, of course. And then I'll re-add the correct constraints. This hole actually goes on this face, apply, and this hole actually goes with that face. And now everything is aligned properly. You'll notice that this does not move. And that's because it's a subassembly, and subassemblies are defaulted into whatever position they are imported in. But it doesn't have to stay that way. I can find my jaw assembly in the tree. I'll right-click and choose Make Flexible. And now with that being made flexible, I can move this subassembly flexibly just like anything else in our assembly. So there is one contingency. If you do have patterned components, it doesn't translate to the assembly level. So off screen I went ahead and reinserted this as a non-patterned component. So keep in mind, if you want flexibility, avoid component patterns. Next, I'll do the same thing, and we're going to say insert design. We'll insert the subassembly again. So same subassembly, but of course we have to orient it differently. I'm going to start by adding a constraint where I want this face and this face to be coplanar. This hole to mate up with this hole. And I'll choose this hole to mate up with this hole. Again, I'm just using the coaxial constraint. And look at that, I totally did it wrong. I should have been working on the other side, which happens. So I'm going to delete the last two constraints from the tree. And we'll go from here to here. So this should illustrate the ease that you have in parametric CAD of correcting things that you do wrong. It's not really a question of if you do something wrong, but when, because assemblies are complicated. But rest assured that when that happens, it's pretty easy to correct. So I've got a fixed jaw over here, and I've got a loose jaw over here. I can edit this to make flexible. And now I can rotate both, and you can tell that whatever I put in this vise, the jaws are going to bend to update whatever we're doing. Next, let's add in a screw, and this will help to actuate our jaws together and apart. So I'm going to say insert design. We'll insert our lead screw. And we'll finish. And we can see that we have a screw with a threaded pitch here. And I know that I want this face that I just highlighted to be constrained to this face. So now they are coincident. We'll apply that. And I want a coaxial constraint from here to here. Just like that. So I've got this lead screw that's mated in. Now what do I do about the handle? Let's insert the handle. I can finish with that. We'll go to constraints. We'll first make sure that this face is concentric with this face, also known as coaxial. And this face to this face. Notice we get an overdefined error, and that's because we can't be coaxial and have these faces be coplanar at the same time, or in other words, coincident. And so instead I'll choose an angle, and I want a parallel angle of 0 to be applied. But of course, I'm off there. And so I'll go back to my angle, and I'll make that 180. And now we're properly aligned. And next, I can select this face, choose this face, and of course, instead of an angle between these faces, I want there to be something that's coincident. And just like that, we've been able to build a vise, except nothing happens when I turn the handle. So how do I do more advanced mates? Well, let's take a look. I'll first align the threads in a way that they look like they're meshing, just for realism. And when I have this all set, where it looks like that they're going to mesh well, I'll go to Constraint. I'll choose this outer face and this face here, just two circular faces, one on the screw and one on the part. I'll go to Mechanical, and I'll say Screw. And I'll enter a pitch of 1, or whatever pitch that my lead screw is. And I have the option to reverse if I have left-handed threads. But I'll go ahead and hit that reverse box and apply that. And now I'm able to screw in a way that is very realistic. So that's how we do more advanced mechanical mates like the screw mate. The gear mate works off the same premise. But let's look at gears in the context of gears. So when we're dealing with gears, what we want to do is go into our constraints, go to mechanical, and we'll choose a round part of the first gear and a round part of the second gear, and we establish the gear ratio, right? We say, what is the size of each gear? I prefer entering the number of teeth, right? So you can have a gear with 30 teeth and a gear with 40 teeth. In this case, the gears are the same size, so we'll just leave the sizes the same, but if there's any question, just enter the number of teeth here and we'll apply that. And now we have a gear mate. Now if you're dealing with something like a belt, right, where the supposed gears would need to turn in the same direction, we certainly can do that. We can go find our gear mate in the history tree, and we'll reverse relative rotation, and now they would rotate in the same direction at the specified ratio. I also have an option to explode assemblies if I wish to show the parts. So I can choose exploded view up here, and you can always choose an auto explode, and Alibre does a pretty good job of automatically exploding an assembly if it doesn't know what it is. At least we can view all of the parts in space. Now we also can choose the degrees by which we're exploded. So I can choose contract, and I can contract it until it looks almost assembled again, or I can expand it further if I'd wish to do that. So you can choose the expand and contract to change how your exploded view looks. But also we can manual explode, right? So I can exit my exploded view, and under exploded views I get this tree item that I can edit my exploded view or exit my exploded view, or I can simply delete. And for exploded views, I can choose manual explode. I can choose a particular component, and with my triad tool I can edit the position of each of my components however I'd wish to explode. And of course I can move two components at the same time if I simply select multiple components using the Shift key. So I can choose all of these and move them all up at the same time, and so on. If I'm happy with an exploded view such as this, I can simply exit my exploded view, and I can re-enter it at any time. So let's talk about a new constraint that we can do. I'm going to insert another design, and I'm going to actually insert one of my cubes. One of the very unique things that we have that we can do in an assembly is we can edit things in context. Not all modelers can do this. If we go to our cube, I can right click on it and say edit here. And what else is interesting is if I go to edit, say, a sketch, I can actually make this related to parts of my assembly, right? If I want my circle center to be on this bottom axis, right, I can start making sketches that are integrated into the assembly. This is known as editing in context. I don't want to do that here, but it is important to know that if you need to relate one part to another part, an assembly edit in context is an option. So I'll deactivate my sketch, but I will actually turn this into a sphere. There's an easy way to turn a cube into a sphere. Fun little Alibre trivia. Let's take a fillet, and we'll give the fillet radius something like 3 inches. I think this is in millimeters, so we're going to say 3 times 25.4. That didn't catch, so 3 times 25.4. There we go. And we can simply fillet a sphere from a cube. So if I have a spherical or a cylindrical face, then I can, and then to get out of this editing, by the way, I'll just say edit part or subassembly at the top of the tree, and now we're back editing our assembly. And if I have a cylinder or spherical face and I want there to be tangency, I can certainly do that. I can click on my 2 constraints or my 2 edges that I wish to be tangent, and of course we come in with coaxial, but I'll change this to tangent. If you can tell, now this sphere is always going to be tangent to this cylinder face. So very, very useful. So that's how we can establish tangency if we want 2 circular edges to be tangent. We also can make drawings with our assemblies. So I can say send to, and I'll probably need to save this, so I'll save this. And after saving, I can say make drawing of this design. And perhaps I'll put it into a template and say OK. From here, I'm given several views that I can insert. I'll select which views that I would like, and note I have many options over here. I also can choose a specific exploded view if I'd wish to insert that. Next, I can delete any views that I don't want, and there I have the views of my assembly that I can dimension, that I can bubble, that I can do anything I like with. I also can go to Sheets and Views, perhaps insert a standard view. Do an isometric exploded view. And it looks like I forgot to delete one of my views, so we'll just use that with the delete key. And now I have an exploded view that was not very graceful from what I set up in the video, but you can see how we can have both an assembled and exploded view for the purposes of our drawing. So that's an overview on how we can establish mates, how we can work advanced mates like screw and gear, how we can use subassemblies and make them flexible. So hopefully this video was helpful. If it was, please subscribe, and we'll see you in the next one.